Okay, problem 17 says for a birthday party, the local pizzeria charges $4 for each adult and $1.50 for each child. If there were 5 more children than adults who attended the party, and it cost $46, how many adults attended the party? So we either have 6, 7, 8, or 9 adults that are going to attend, and then there are going to be 5 more kids than that for each case. So what we're going to do is look at the facts here. We know adults cost $4 a piece, kids cost $1.50. There are 5 more kids than there are adults, and this party is going to cost a total of $46. This is an example of one of those systems of equations problem that we've talked about, system of equations, where we have 2 equations. In this case, one of the problems, or one of the equations, is going to deal with exactly how many kids there are and how that compares to the number of adults. And the other equation is just going to deal with the money that's involved in the situation. So let's let the letter A represent how many adults we have. And what we'll do is we're going to let C represent the number of children in this problem. Now, I already know how much each costs, so these don't represent the cost. They just represent how many adults and how many kids show up. So I know there are 5 more children than adults. That means if I want to figure out how many kids there are, I just take the number of adults and I add 5. Right. So there's one equation. Now the next equation tells me how much the total cost of the party is, and I know that for every adult it's going to cost $4, so I do 4 times the number of adults plus $1.50 per child, so $1.50 times the number of kids, and altogether the total cost should be $46. So I already have 2 equations here. This is my system. Sometimes you'll see a little squiggly curly brace in front of your system. So that lets us know these equations go together and they're sort of need to be working together at the same time. Next step, I notice that I have an equation that says C equals all of this over here. That means when I look at this second equation, I can replace this letter C with everything that it's equal to, which in this case is A plus 5, so that is the substitution that we've talked about before. That's the substitution method. So we take 4A plus 1.50 times A plus 5, and altogether that equals 46. So I've plugged in A plus 5 for C here. Now we just need to simplify this. That means I need to get rid of the parentheses over here. I'm going to bring this 4A down. 1.50 times A is 1.50A plus 1.50 times 5. You could type that in your calculator. I'm going to save you a little time, and that's going to give you 7.50. And all of that is going to equal 46. Now we look at this and we can simplify it just a little bit more. We have 4A plus 1.50A. Add those numbers up and we get 5.50A plus our 7.50 still, and that is still going to equal 46. Now this is just a simple equation. Got a number times A plus something else equals 46. Let's try and work through and solve this. To cancel out the 750, we're going to subtract it from both sides. So these go away, and I'm left with 5.50A on this left side, and that is going to be equal to 46 minus 7.50. If I subtract 7.50 from 46, again we could type this into a calculator, so I'll just do this one. 46 minus 7.50 is going to give us a total of 38.50. So let's go back to the problem, and we know that that equals 38.50. Now, once we get here, I've got 5.50A equals 38.50. If I just divide out that 5.50 on both sides, that cancels everything out over here except for the A, which is what we wanted to do to figure out how many adults there were. So I divide this side by 5.50 as well as this side. Again, you could take your calculator and divide 38.50 by 5.50, and what you're going to get is 7. Okay, so that means there are 7 adults. If I wanted to know how many kids there are, I would just take this number now, and we would plug this number right back in, way up here. So I know that the number of kids is equal to the number of adults plus 5, so that's going to be 7 plus 5, which is going to be 12. So 5 more than 7 would give us 12 kids. So there's 7 adults and 12 kids. So if we look back at the problem, see what it asked again. It asked how many adults attend the party, so our answer is B, 7 adults. And we're done. So hopefully that made sense. This again is another systems of equation problem. Number 16 was as well, so if you need more practice on these, make sure you check these out and then work on the other practice problems that we've been given in class. So hopefully this made sense, and then you can go on to the next